This lecture is for chemistry in the Earth system as we continue Unit 1.1, talking about heat. In this lecture, we will attempt to build a response to the essential question, what is the difference between thermal energy and temperature? What is the difference between thermal energy and temperature? Thermal energy versus temperature. Thermal energy versus temperature. Thermal energy and temperature are terms that have specific definitions in physics. The thermal energy of an object is the sum of all the kinetic energy of its molecules. Its temperature, on the other hand, is a measure of their average kinetic energy. Different objects with the same temperature can have very different thermal energies. For example, seawater in the ocean and seawater in a bucket can have the same temperature, meaning the same average kinetic energy. However, the ocean will have more thermal energy because it has more molecules. Molecules of water in that bucket, they do have kinetic energy. This would be low if the water were frozen, which is represented on the screen here. It would be higher if it were liquid, which is represented again on the screen here, and still higher if it was vapor, as we can see on the screen here. But for the same mass of a substance, molecules of vapor have more thermal energy and higher temperature than those of a liquid. Molecules of a liquid have more thermal energy and a higher temperature than those of a solid. Units for temperature. Units for temperature. Temperature is typically measured using one of three common scales. First, the Fahrenheit scale. This scale is in everyday use in the United States. It uses the freezing point of 32 degrees Fahrenheit and a boiling point of 212 degrees Fahrenheit of water. And so the Fahrenheit uses the freezing point and boiling point of water as reference points. It divides the range between them into 180 equal degrees. Although almost all of the rest of the world has abandoned it, the Fahrenheit scale does have the advantage of having divisions that are smaller compared with those of the other two major scales. This allows for a greater resolution of temperature. The scale is specified by using either the notation degree F for the phrase degrees Fahrenheit. Secondly, we have the Celsius scale. This scale is in everyday use throughout most of the world. It is used in science and is increasingly used in industry in the United States. It also uses the freezing point and boiling points of water as reference points, but it sets them at a convenient temperature of 0 and 100 degrees Celsius, respectively, and dividing the range into 100 equal parts. Temperatures below the freezing point of water are considered negative. The scale is specified by using either the notation degree C or the phrase degrees Celsius. And thirdly, the Kelvin scale. This scale is in universal scientific use. Its divisions are the same as the degrees on the Celsius scale. The lowest possible temperature is set to 0, specifically absolute 0. At absolute 0, there is no energy from molecular motion available for transfer to other objects. Absolute 0 on the Kelvin scale, which is represented as 0K, is equivalent to negative 273.15 degrees Celsius. It is very difficult to produce the conditions required to observe matter at this temperature, even if it is possible. A laboratory in Finland has been able to supercool a piece of rhodium, to 0.000000000001 Kelvin, or 100 picokelvin, above absolute 0. So very, very close, but never actually absolute zero. In contrast with the other two scales, the word degrees and the symbol, that superscripted circle, are not used for the Kelvin scale. For example, you would not say 2300 degrees Kelvin, you would say 2300 Kelvin or 273 Kelvin, not degrees, Kelvin. At this point, you should be able to build a full and complete response to the essential question, what is the difference between thermal energy and temperature? What is the difference between thermal energy and temperature?